Hi children, in today's maths class we are going to see chapter 7 mensuration, exercise 7.3, questions 4, 6 and 7. Question number 4. Read the question carefully children. A solid consisting of a right circular cone of height 12 cm and radius 6 cm standing on a hemisphere of radius 6 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of the water displaced out of the cylinder if the radius of the cylinder is 6 cm and height is 18 cm. First I want to discuss about the cylinder. See the last line of the question. What is the radius of the cylinder? 6 cm. What is the total height of the cylinder? 18 cm. Okay, so a cylinder of height 18 cm and a base radius 6 cm. It is full of water. Okay, they placed a object upright in the right circular cylinder. What is the shape of that object? Okay, they placed a solid. Okay, that is object, both are same only. So they placed a solid upright in a right circular cylinder. What is the shape of the solid? The solid consists of a right circular cone. What is the height of the cone? 12 cm and radius 6 cm. Okay, that cone is standing on a hemisphere whose radius is 6 cm. Understand children? So at the bottom hemisphere, on the hemisphere the cone is standing of height 12 cm. The radius of the cone as well as the radius of the hemisphere is 6 cm. Okay, they placed this solid upright in the right circular cylinder which is full of water. So if you place that solid in the right circular cylinder, what will happen? Some water will displace out. No? Now they ask you to find out the volume of the water displaced. Understand children? See the diagram. Now I hope you understand the question. Okay, height of the cylinder is 18 cm. 6 plus 12. 6 is the height of the hemisphere and 12 is the height of the cone. But total height of the cylinder is given as 18. Understand? So height of the cone is given as 12. Radius of the hemisphere is 6. Already I said the radius will act as the height of the hemisphere. So radius of the hemisphere, radius of the cone, radius of the cylinder, all are same, 6 cm. Understand children? Solution. Take and write the given things. Radius of the cone R 6 cm. Height of the cone H 12 cm. Radius of the hemisphere, that is also 6 cm. All are same, so I am keeping R in both the places. Radius of the cylinder, that is also R, because the measurement of the radius of the cylinder also 6 cm. So R. Common means we can have a common name. Height of the cone is 12 cm. H, small h, that is 12 cm. Height of the cylinder, whether the height of the cylinder or cone are same? No. So it was different. So we have to differentiate it. So height of the cone I mentioned by using capital H, that is 18 cm. Understand ma? Now you tell me children, how to find out the volume of the water displaced ma? Volume of the water displaced out of the cylinder is nothing but that is equal to volume of the solid, that you know very well. So how to find out the volume of the solid? Volume of the solid equal to volume of the cone plus volume of the hemisphere, isn't it? That is the total solid, isn't it? Volume of the cone plus volume of the hemisphere. Now you substitute the formula. Volume of the cone 1 by 3 pi r square h plus volume of the hemisphere 2 by 3 pi r cube. Now we can take the common term outside. Here 1 by 3, here 1 by 3. 2 by 3 means we can take 1 by 3 outside. Pi is common. R square, here r cube. So we can take r square as common. Now 1 by 3 pi r square I am taking common. Okay, so what is the balance here? Only h. Here 2, in the numerator 2, here 1 r. So 2r is balance. Now we can substitute the value. 1 by 3 into pi value 22 by 7 into r square. R value is 6. So r square means 6 into 6 into h value 12. Small h. Volume of the cone, yes ma. Volume of the cylinder only capital H. Volume of the cone small h only, no. That value is 12. So 12 plus 2r. 2 into r value 6. Now 1 by 3 into 22 by 7 into 6 into 6 36. Inside the bracket 12 plus 6 2s are 12. Now see here, we can cancel 3 and 36. What you will get, children? 12. So 22 by 7 you take and write as it is. Then cancel and write 12. 12 plus 12, 24. So if you multiply 22 into 12 into 24, what you will get? 6336. What the denominator? 7. So divided by 7. Divide it. You will get 905.14 centimeter cube. This is the volume of the solid. Okay, that is nothing but volume of the water displaced out of the cylinder. So volume of the water displaced out of the cylinder equal to 905.14 centimeter cube. It is a 5 mark question, children. I hope you understand the sum, children. Yes.